so this and the next three questions, total set of four questions, they are relatively easy questions, straightforward application of the law of reflection and law of refraction. Most of them use law of refraction. So let me write down those laws that I'll be using, and I'll work through all four questions. For the sake of, I guess, completeness, there's a reason I haven't done these questions yet. Because they were easy. I thought they were easy, so I thought, hey, I don't need to do it. People in my class can do it. Now, I still think you can probably just do it, but I'm close to finishing all the homework questions, so I'd like to finish them all. So let me write down law of reflection. Simply stated, it says that angle of incidence is equal to angle of reflection. And to be clear about the angles, the way we measure angles in optics is relative to the surface normal. So let's say a light comes in like this. Sometimes people looking at this drawing might have I don't know, intuition to draw angle here. And that's not how we define our angles. We define it relative to the surface normal, the perpendicular to the surface, and this is how we define angle of incidence and angle of reflection. Now, for the law of reflection, it might not matter, because if these angles are the same, then yeah, supplementary angles will be the same too. But it matters for really two reasons. In a kind of three-dimensional space, this is the way to unambiguously define an angle. The angle to the plane is kind of a little bit complicated. And the other second reason is for the law of refraction. It actually does matter that you are using the angle relative to or Snell's law. It doesn't matter that you are measuring the angle relative to the surface normal, because there's more mathematical function in the way. So for the law of refraction, if you are going from a medium of index of refraction n1 into a medium of index of refraction n2, then the light will refract as in bend as it enters. Let's say n2 is bigger than n1. Then defining the surface normal, we can draw these angles theta 1 and theta 2, and they are related this way. N1 times the sine of theta 1 is equal to N2 times sine of theta 2. So we'll be using these two expressions to work out these four questions you will see. The first question says, a light beam in air has an angle of incidence of 10 degrees at the surface of a glass plate. Oh, yeah, so reflection will be 10 degrees. That's the simple, easy law of reflection. The angle of refraction. Now, so I need a form of this equation that's been solved for theta 2. In the interest of time, I'm going to do that algebra in my head. Theta 2, as long as it's on an acute angle, what I'm going to write down is fine. It's arc sine of n1 divided by n2 times sine theta 1. And for small angle, you might be able to kind of cancel arc sine and sine, but let's not do that. I have a calculator here. I can just, type arc sine of n1, that's 1 air, divided by the glass, 1.5 times sine of the angle, 10 degrees. And O from alpha will give me an angle. I do have to be careful. So this is in radians. Okay, converted to degrees. That's great. 6.648. I could also enter, as long as you keep minimum 3 significant figures, the system will grade it as correct. System operates on a tolerance of default 1%, and 3 significant figure ensures that your rounding error is no more than 1%. So that's question 1. Let's look at the next question. So unless otherwise specified, so light ray crosses from water into glass. Okay, I can use this exact same setup. The only thing that changes is N1 is now index of refraction of water, not air. So I can even use this exact same expression. Just need to turn 1 into 1.333. Wow, is it 10 degrees not randomized? Okay. It might not be randomized. So I get the radian answer first, and then the degree answer is, so I guess that means it refracted less, I think. Because it's closer to 10 degrees. Wait. Oh, wait. I gotta read the question. Sorry, I thought it was asking about angle of refraction. What? Oh, I really gotta read the question. What it's telling me is it emerges at an angle of 10 degrees and wait, water into glass emerges. Oh, I guess emerges on the glass side, I think. Yeah. So theta 2 is 10 degrees. Okay, I got it. So I need a new algebraic expression that's solved for theta 1. Looks quite similar. I'm gonna just do it in my head. You can double check me, do it on paper or something and make sure I'm not making any mistakes like I was making with the not reading the question thoroughly. So now I can plug in, okay, N2 is glass. That's 1.5. N1, that's water, 1.333. And angle of incidence, wait, no, this is outgoing angle, 10 degrees, that's fine. So the incidence should be bigger than 10 degrees, I think. Yeah, 11.27, all right. 11.3 should be graded as correct. That's right on the boundary because, this one number is kind of small, but as long as you keep three significant figures, rounding error alone shouldn't cause your answer to be graded as incorrect. All right, I got two more questions. All right, this is the next question. So light rays from the sun make a 29.5 degree angle. Is there some way for me to use this diagram still? So theta 1 is 29.5 degree. Okay, I think. But it says when seen from below the surface. Okay, so I think what it's trying to say, so if I'm interpreting the question as written correctly, then what it's saying is the theta 2 is 29.5 degrees. Because it's looking at the angle of the light ray when seen from below, reference to vertical. So now I can work out theta 1, and if I plug it in, it'll say it's wrong. Because it's not actually asking for theta 1, it's asking for at what angle above the horizon is the sun. So it's asking for this angle that we don't actually use to specify Snell's law stuff. But let's work out theta 1 first, and all I have to do is subtract that from 90 degrees. So theta 1, in this version, I think it's this equation again. I already worked out the algebra. So N2 is the water, 1.333. And N1 this time is air, just 1. And theta 2 is 29.5 degrees. That'll give me theta 1, which is not the answer, but I subtract that from 90, so that's 48.97, which you could round it to 49.0, but let's just plug this in and hope that that's correct. So, yeah, so that's the third question, fourth and the last question in this group. Again, the group of questions that I thought were easy, and maybe they are easy. I'm just trying to complete everything because these 4 questions are getting in the way of me having done every single homework question on video. The path of a light beam in air goes from an angle of incidence of 35 degrees. Oh, wait, this is different. They're actually giving me both angles. They're giving me both the theta 1 incidence and theta 2, 30 degrees. They told me air, so they gave me N1. And so the only thing they haven't told us is N2 and asking for that. So So I gotta solve this for N2. Oh, this reminds me of the lab you will be doing next week. That's the really one main activity in that lab is figuring out index of refraction of a medium in a few different ways. So N2 is equal to N1 times sine theta 1 divided by sine theta 2. And I wonder, these angles might be small enough where small angle approximation works or not. It might be off by enough. Let me give this a try. So I'll give an answer using small angle approximation. And if it tells me it's wrong, I'll then not use a small angle approximation. With the small angle approximation, we say n times just the angle. Now, normally you have to do it in radians. But because I'm going to be dividing two angles with each other, so the whole conversion factor from degrees to radians will cancel out. So I'll just keep doing it in degrees. So when I do this, numerical answer 1.522. And there's a good chance that 50-50, if it might be graded as correct or not. It's not graded as correct. Okay, that was the other 50. So let me actually work out the exact answer. Sine of 30 degrees divided by sine of 23 degrees. My bet is it's like off by a couple percent. And that's enough to make it not correct. 1.468, yeah. So 468 compared to that, that's, yeah, like less than 5%, which is traditional threshold we use for small angle approximation is good, but the grading system here is programmed on the basis of small, the 1% tolerance. So 2, 3, 4% error, small, but not small enough for our grading system. So that's the last question in this group. Thank you.